Looking for the ideal system for a small home office where I can work without worrying about power blackouts, I came to the conclusion that solar energy can be combined with a simple charger represented in the drawing by T1 transformer and DB1 full wave rectifier, in order to keep the batteries floating and available at night for LED lights both in the office and in the rest of the house. The first thing would be to have a solar panel of the ideal power rating to keep the computer running even on cloudy days. Also, the charge controller should have the equalization function disabled to avoid a relatively high voltage to be applied to the batteries, causing the inverter to shut down. With such a system, you can work around the clock as long as there is sunlight, without worrying about power outages, which could last all day long. Naturally, the inverter, being non-sine wave in my case, must be able to produce the power required by the computer, office light, and a ceiling fan for hot places. In my case, I added T2 transformer to step the voltage delivered to the computer down to approximately 100 volts. A transformer can be operated as an isolation type to protect the inverter against any ground leakage that could damage it. An additional transformer would step the voltage down for the LED lights down to 90 volts to protect the LED lights, since the modified sine wave of the inverter shortens their useful life. Finally, I connected all the LED lights around the house, so in the event of a power blackout at night, my lights will keep shining. Of course, I had to use separate wiring for my lights in order to avoid the risk of a ground leak. As for the charger, its output current can be fine-tuned by using, in the primary of the transformer, a dimmer originally designed to dim incandescent light bulbs, and I'm using it here as a trickle charge controller. The dimmer is available online at low cost. I have been using the full system for over a week now, and it has worked quite well for me. I use the computer about 8 hours a day while the batteries are being charged by the sun, and during part of the night the charger prevents the batteries from running down, keeping their charge. An additional note about the charger is that it turns on only at night by means of a relay, normally intended for 110 volts AC, energized by the voltage produced by the solar panel. When the sun shines, the relay is energized and disconnects the primary of the charger transformer so that it does not interfere with the normal charging of the solar power system. A couple of measuring instruments may be added to the system: a voltmeter for showing the voltage reached by the batteries, and an ammeter which reads the floating current being fed into the batteries at night. I hope this video has been useful and inspiring for you. Thanks for watching, and please subscribe to my channel. Chava Tarim.